Good afternoon and welcome to the Slumberger Academy for the fourth appointment. Today we are talking about acoustic log, also called sonic log, and we analyzed how we can use acoustic logs, the different type of acoustic logs, characterize and formation, how we can use for characterize formation porosity, lithology, and mechanical properties. So in this case, with acoustic sonic log, it is possible to use and to measure, is used to measure slowness, the time it takes for an acoustic wave to travel 1 foot usually, lower when the difference time is very lower, that it means that we have a faster wave speed, and so faster wave speed corresponds to a denser rock. When we have a small, a very high difference of time, we have a slower low speed, so that means they have that the wave comes from through more porous and fractal rocks. So tools also provide an analysis of compressional wave and travel time, shear wave as wave travel time, Stonel wave, and so in this case we are just talking about acoustic logs, also called sonic logs, and it is to use to characterize the formation porosity, lithology, and mechanical properties. So this kind of application is generally to use for porosity estimation, using well-timed average equation of Reinmer and Garden models, fractal detection, also anomalies, attenuation or dispersion in waveform or slowness. And also we have the lithology identification, velocity constants help differential between sands, shale and carbonates, geomechanical, calculation of Young modulus, Poisson ratio and bulk shear models, cement bond evaluation. In this case we are use also acoustic log when we make cement bond, cement bond. So when we are cementing the wells. In this case, acoustic log can evaluate the bond between casing and the formation. Seismic to well tie, generally the synthetic seismogram from acoustic log. Also in this case, we are talking about to wear porosity and record slowness. So we are very talking about acoustic logs. Also we can make some example when we can perform that in different way. The first example is around the formation evaluation. So the formation evaluation is generally performed in geothermal and in also oil and gas. A record of some acoustic properties of the formation of boreal. The term is sometimes used to refer specifically to the sonic log, in the sense of the formation compressional slowness, although it may also refer to any other sonic measurements, for example shear or flexure or stoneless or amplitudes, or to ultrasonic measurements such as the boreal televiewer and other pulse echo device, and even to noise log. So it's clear that in this case, when we are talking about the acoustic log, the use of televiewers across all industries, including mining, exploration of production, geotechnical engineering, university, research and groundwater exploration, both acoustic and optical televiewers have become mainstream in subsurface investigation and provide valuable information about lithology, fracture, structure, fraction, and stress oriented within the boreal. So it's clear that the sonic log is very useful in all phase of exploration, all phase of formation evaluation, both in oil and gas and the geothermal project. So we have some specific application also in mining, but is minus used than magnetic log. So different way to execute acoustic log. For example, we have the televiewer system. So in the televiewer system we generally have two kind of televiewer system, the digital and the analog. So the acoustic televiewer and the optical televiewer. So we are checking the difference between the two systems, acoustic televiewer and optical televiewer. So it's clear that televiewer application, detailed and oriented structural information, reference for core orientation, fracture detection and evaluation, breakout analysis, detection of dim beds, determination of bending deep, orientation of stress tense, or lithology and mineralogical characterization. Case inspection is generally repeatable and precise, continuing high resolution in situ measurements, easy to confirm accuracy by comparing between optical televiewer and synthetic and acoustic televiewer, between ATV and OTV logs. Generally, the most important difference between two systems, two way of executing acoustic log between acoustic televiewer and optical televiewer, and also we have also different in type and when we can use one or the else. For example, acoustic televiewer is really recommended from extract some geological information to hard rockness or coarse or fine texture. Optical televiewer is very useful because it is a high resolution to 1 millimeter, full color digital 3D core. Fractures, the log is very sensitive to fracture, especially in hard rocks. Instead, optical televiewer, smart fracture can be lost in complex imagery. So boreal diameters 5 to 7.5. So we have as smallest diameters for optical televiewer, for application optical televiewer. We can execute optical televiewer without mud or in dirty water. To execute, for example, another difference to execute acoustic televiewer is required fluid and filled boreal, mud or water. Optical televiewer, drier or clean water filled bore. Rocks well in water based in drilling mud, does not work in oil based mud. Limited use in polymer mud bases. Some geological information is available related to rocks from hardness, and for example, there is also difference between for identification of fractures. The log is very sensitive. The acoustic televiewer is very sensitive for to identify the fracture, especially in hard rocks. Optical televiewer is really recommended for small fracture and can be lost in complex lithology. Watershed zone, describe watershed zone with acoustic televiewer, well due to rock hardness and sensitive. Watershed zone is not so easy with the optical televiewer, and also there is a very small difference resolution between the difference in resolution between acoustic and optical televiewer. So it's clear that in this case we are talking about of different techniques and different approaches. Here there is a small image that make a comparison between the results of acquisition of acoustic televiewer image. You can see there is, for example, the fracture and contact between two geological layers is not so is in evidence, but is not so clear. So in optical televiewer, the join between two geological layers and fracture is especially fracture. This fracture is too easy to identify. So we have also the table plot to identify the deep and the spatial correlation. When we can recommend to use, for example, acoustic televiewer instead optical televiewer, we have a specific application that is really good for acoustic televiewer. Boreal formation to analyze, make, for example, stress field analysis in boreal formation. So for geomechanical analysis, structure detection and evaluation, breakout analysis, detection of fin beds, determination of bending clip, lithology characterization, rock strength, causing inspection and corrosion evaluation, steel casing thickness. So the casing, when we are measuring, for example, in bone cement, the different thickness of in the final cementing, the different thickness of cementing is really recommended using acoustic televiewer. So, which is the best operation? Boreal field with water, we need to have water or also mud. Casing, we can the casing in this case is generally we can use a cheapest cases also in PVC for boreal and case steel. Centralization, feature and benefits. Higher log speed of rotation of the mirror can reach up, in this case, choosing azimuthal resolution expected to trace for the mirror resolution. Dynamic range of measuring extend to 16 bits. Improve signal noise ratio, and also we have casing thickness algorithms and processing refined. So generally the cost and also the casing for acoustic televiewer is essentially cheap, because we can use also PVC casing for boreal. In this slide, we have the details for optical televiewer. The operating condition we recommend is also clean water. We don't have to need mud, absolutely no mud, because you can see this is the chart. So you can see the effects of sensor optical televiewer, lighted optical televiewer. So it's very important because it is not support the presence of mud. And the casing we can do with open hole, PVC boreal, or also steel. Steel is very recommended when we have fine segments, and also characterization. We have some benefits, also application for detailed and oriented structural information, reference for core orientation, fracture detection and evaluation, breakout analysis, detection of behind determination, and lithological mineralogical characterization, case inspection. So in this case we are talking about, we have an example of optical televiewer restitution, so it's really helpful to identify fracture, volume of fracture, orientated of fracture, so, and also geological, and also the presence of subsurface geological patterns, so it's very helpful to do this kind of works and these kinds of job. Another type, also we have the optical telegraph application, is a extract from recent work, logger suite application. Here we can see a contact, a very regional contact. Here we have, for example, an image optical reviewer in carbonate dolomite zone broken in dolomitic sandstone. So is a good example from works. Thanks for attention. In the next appointment we are talking about the last two types of acoustic logs, full wave triple sonics and acoustic log Pt1. That is another type of investigation, also in Boreal, that make correlation between P and S wave. Thanks for your attention.